Tengo que dar a la gente. Da la gente lo que quieren. Oh, vocals. Bass. Back. Like this little Spanish intro. I gotta memorize it though, so I don't have to look at the phone. Hopefully I didn't mess up. We're gonna get deeper into Gema tables right now. It's the deep cuts Gema tables. It's not the, never mind, let me stop. All right, anyways. Make me a Gema table for this, y equals x squared. This is actually called a parent function. This is the most basic parabola. At its most basic form, y equals x squared. Make me a Gema table for that. Do it right now. Cool. Hopefully you just did it and you're like, oh, that's a simple Gema table, Bass. I'm gonna start with x. I'm gonna square it. That's about it. My vertex is going to be 0, 0. 0 squared equals 0. -1 squared is 1. 1 squared is 1. -2 squared is 4. 2 squared is 4, right? We don't even actually need the rest of this part right here, okay? So this is my parent function, and actually underneath it, I'm gonna say parent function, right? This is the most basic quadratic you could have. Now, go ahead and make me a Gema table for this one, okay? So, you pause, you do it before me because you're cool like that. And now, I'm gonna do it and we're gonna just check to make sure that what you did was correct. So let's see, we start with the x. We add 5 to it. We square it. We multiply it by 0.10. And then we add 10 to it. Okay, so we set it up just like so. Now we're going to look at our vertex. It should be -5, 10, so let's go ahead and put that in here. X is -5. -5, what's that? Plus 5 is 0. 0 squared is 0 times 0.10 is 0. Yep, -5, 10 is what we want for our vertex. And we're not going to show all the intercepts and everything, but we're just going to look at some of the symmetry. So this is -5, so backwards this would be -6. This would be -7, -7, -6, -5, -4, and -3. Okay? -6 plus 5 is what? -1? Yep. -1 squared is 1. 1 times 0.0 is 1 times 0.1 is 0.1, and plus 10 is 10.1. Alright? -7 plus 5 is -2. -2 squared is 4. 4 times 0.10 should be 0.4. Plus 10 is 10.4. -4 plus 5 is 1. 1 squared is 1. 1 times 0.10 is 0.10. And 0.10 plus 10 is 10.10. And finally, -3 plus 5 is 2. 2 squared is 4. 4 times 0.10 is 0.4. Plus 10 is 10.4. Hopefully, I'm just checking to make sure I'm still recording. I am. So hopefully you got all that on your paper before me, all right? But there are a couple of things that I want you to notice. So I'm not gonna erase this. First, this parent function that we were talking about. Look at this function right here. and look at it right here. The exact same parent function will always happen right in the middle of this table, okay? So notice that, like, I know this thing is right because if I get my right vertex, I'm gonna end up with 0, 0, and I'm gonna end up with this same parent function, negative 1, 1, negative 2, 4, 1, 1, 2, 4. I'm gonna end up with that same parent function right inside my Gema table. So that's an important detail to recognize, that that's gonna happen. Everything else happens around this parent function, okay? Now, let me erase this part, because I'm gonna write something here. You can probably stick yours in, but I need to write this right here. You could probably fit it on your paper. Now notice, at this position right here, I want you to draw this line. On this side, we're actually talking about inputs, right? This is stuff that is happening to X, right? This is all the stuff that's inside this parentheses that is adjusting what's happening to X. Like I put 7 into X, but then I need to take X plus 5, right? So this is all talking about inputs and how we're adjusting inputs. But at this point, right here, all these over here now start talking about outputs. Like I put negative 7 in, and then I had to add 5 to it to get negative 2. So ultimately, what is inside this parent function, the thing that's being squared, was a negative 2. So that was an input because it's inside this part that's being squared. It's in the parent function. And now that I know what's the thing that's being squared, all the rest of this is what happens to my outputs. Well, my first output in my parent function, like if I took this negative 2 and squared it, I'd get 4, right? But then I have to multiply that by 0.10. My output needs to multiply by 0.10. Then I need to add 10, right? So all these are outputs. These are X values over here, these inputs, right at the point where I get all the stuff inside the parentheses that would be inside this parent function changed. Then we get to outputs. These are all Y values over here. So noticing this is the line where I change from inputs to outputs, okay? In class, at least in my class, I always recognize that, notice, this vertex always has this middle row of zeros. You're always going to see it. My vertex here, even over here, my vertex has this middle row of zeros. I know my vertex is right when I end up with 0, 0, 0, 0 up until the last piece of it. So I want to make sure that I have that. So we did the input-output change, we did the vertex with the middle zeros, we did the parent functions, we've talked a lot about x-intercepts. Let's do one more of these and talk a little bit about a couple of other pieces to see, and then we will be done. So I'm gonna let you make one more Gema table and then we'll deconstruct it a little bit. Why don't we make a Gema table for y equals negative 10 times x plus 1 squared minus 40. Make me a Gema table for that one, please. I am guessing that you paused and you just did it because you are cool. So I'm going to make this Gema table right here too. We have x, we have a plus 1, we have it squared, we have a times negative 10, x plus 1 squared, and we have a minus 40, negative 10x plus 1 squared minus 40. All right, let me check to make sure I'm still recording. I am. Okay, now let's go ahead and get our vertex. So I'm gonna do it right down here. You should know that our vertex is what, negative 1. X is negative 1, y should end up being negative 40. Let's see if that works. Negative 1 plus 1 is 0. Hey, we got those zeros. 0 squared is 0. 0 times negative 10 is 0. 0 minus 40 is negative 40. Cool. I see that row of zeros at the vertex that I was talking about. All right? Now, let's start moving around this. Let's find our symmetry. So negative 1, negative 2, negative 3. And then we got 0 and 1. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 minus, times negative 10 is negative 10. Is that right? 1 times negative 10 is negative 10. Negative 10 minus 40 is negative 50. 3, negative 3 plus 1 is negative 2. Negative 2 squared is 4. 4 times negative 10 is negative 40. And negative 40 minus 40 is negative 80. Let's see if we look. 0 plus 1 is 1. 1 squared is 1. 1 times negative 10 is negative 10. And negative 10 minus 40 is negative 50. My symmetry is looking good so far. And finally, 1 plus 1 is 2. 2 squared is 4. 4 times negative 10 is negative 40. And negative 40 minus 40 is negative 80. My symmetry is looking great. Am I still recording? Yep, I am. So my symmetry looks great. Notice, I can see my parent function right here. I want you to label on your Gema table right now, where does this graph talk about, where does it change from inputs to outputs? Go ahead and label that spot right now for me. Hopefully, you saw it's not until this piece starts getting squared that we do that. So right here is where we change from inputs to outputs, okay? But now the other part that I want you to see is let's look at this vertex and let's look around it. Let's say we were gonna graph this. Right, I could look at this and I say, okay, I know the vertex is here. It's at x is negative 1, y is negative 40. So it's like something down here. And then I see when x is 0, y is negative 50, which would be like down here. When x is 1, y is negative 80, which would be down here. When x is negative 2, y is negative 50, which should be down here, which should be mirroring. X is negative 3, y is negative 80, which should be down here, right? This parabola looks like this. This is called my A value. This negative 10 tells me if this thing is going to be concave down or concave up. This is negative, it's going concave down. If I change this to positive, it would be going concave up, okay? So the A value, I'm going to erase this. You're not going to erase it because you don't need to, because you have a whole notebook to write in. But I'm going to erase it. Right? I'm going to say, remember this was A, B, C. This A value, the A value is positive, concave up. The A value is negative, concave down. Okay? Also, for the A value, if this A value is a fraction, right? Something between 0 and 1, I believe the parabola gets wider. And if the A value is greater than 1, the parabola